Good day, viewers. In this section, we are going to introduce the second method, the component method, and we are going to make use of it to solve the last two examples we solved using head-to-tail arrangement. But it's good before we delve into the solution with component method, we remind ourselves about some trigonometric relation. So here is a diagram where we have a vector v, okay, inclined at an angle theta with respect to the x-axis. This vector v has two important sections here. We can see that the reflection of b along vertical axis, this vertical axis, the y-axis, we can term it by. And this by can make sense when you look at the b from this side. Looking at b from this side will give you you will only see the image of v. That if you are looking at b from this side, the height from here to here is what you will see, and this height from here to here is the vertical representation of b. Similarly, when you look at b from this side, you look at it down, you can only see this distance from here down to here as the reflection of b along the horizontal axis. So this reflection of b along horizontal axis, which is bx, and this image of also reflection of b along y-axis by, these are the terms, these are what are called the components of b. The horizontal component bx and the vertical component by. The horizontal component and vertical component and b are related by Pythagorean theorem. You can easily see that here we have right angle triangle, and therefore b is the hypotenuse, so they are related in this way, that b square is equivalent to bx square plus by square. This is the important relationship we are employing in solving our problem. That is one relation. But how do you get bx? Bx is adjacent to theta, while b is hypotenuse. Therefore, adjacent side over hypotenuse side is equals to adjacent. This is adjacent to theta, so it's going to be bx over hypotenuse is our b. Okay, and similarly, and this is adjacent over hypotenuse is going to give you cos angle theta. Cos theta. This is our angle theta. And from here, you can easily see that your bx is equals to cross multiply b cos theta. This is very important, that the reflection along the x-axis is the original vector times the cosine of angle between the vector and the x-axis. So this is the one relation. Beside this one, this is the definition. Then to get bx, we employ this formula. Similarly, by here can be obtained as b sine theta, since by is opposite. This is our by. So it's opposite to theta, and opposite over hypotenuse will give you sine theta. So this will give you the vertical component. This will give you the horizontal component. So for all vectors, we are going to evaluate all the vertical component and add them together and get all the horizontal component and add them together. Then when we have the horizontal and vertical component, then the original vector can be obtained from this relation. So let's here is our first problem, where we resolve the two forces F1 of 15 Newton and F2 of 10 newtons. Okay, 10 newtons, and they are acting such that they are 60 degrees apart. So to apply a component method, we draw a line here to represent our x-axis, and we try to assign some angle here which the F1 make with the x-axis. So here we can assume 65 degrees. Remember, this one we are introducing is not going to change, affect the orientation of F1 and F2, so therefore it will not affect our result. We can change the value here. Okay, so in this case, we are going to resolve F1 and F2 to get F, and that final F is going to be evaluated as follows, as our resultant. Okay, so our resultant R square is going to be obtained from x square plus y square, where our x is going to be obtained from here f1 cos theta 1 plus f2 cos theta 2, and y equals to f1 sine theta 1 plus f2 sine theta 2. So what are our theta 1 and theta 2? So we have to be careful here to evaluate to identify the f1 and f2. The theta is evaluated anti-clockwise. So our theta 1 is 65. Theta 1 is 65 degrees. And our theta 2 is going to be evaluated also anti-clockwise, the angle between our F2 and the x-axis, and this is going to be 125 degrees from 65 plus 60. So we have finished here because we know our F1 is 15, our theta 1 is 65, our F2 is 10 newtons, and our theta 2 is 125 degrees. So what remains is to substitute these values and evaluate, and when we finish, we can now use our final value of x here and final value of y here to find the resultant of the two forces F1 and F2. So let's use our calculators and evaluate this. Our F1 is 15 cos theta 1, we can evaluate that. This is going to, if you calculate values here, the value of the x is this to 475, which will give us our resultant R something very close to 21.79 Newton. Okay, this is our final result. Okay, here is our second example where we have three vectors. The vector number 1 is 100 Newton, vector 2 is 80 Newton, and the third vector is 40 Newton. In our example where we use a head-to-tail arrangement, you can notice that the angle between 80 Newton and 100 Newton is 90 degrees. So this angle from here to here is 90 degrees. This is because if here is 30, here is 30, here is 60, because the angle between x and y is 90 degrees. So this angle is still 90 degrees. And also the angle between 80 Newton and 40 Newton in our previous example is 103. So if here is 30, here is 60. 60 plus 43 is going to give you 103. So this is the same example we had of the three vectors. So let's analyze this one so that we can employ the component method in solving this case. So we draw our axis here, x-axis and y-axis, and the angle we select that 100 is making with x-axis is 30 degrees. You can select any other angle, provided the angle between 180 is 90 and 80 and 43 is 103. Here can be any angle. So if we select 30 here, if it is 30, then our theta 1, which is the angle between the our F1, okay, this is our F1 of 100 Newton, this is our F2, okay, 80 Newton, and this is our F3. Okay, so our F1 is 100, our F2 is 80, our F3 is 40 Newton. The angle between F1 and the x-axis is 30. You can see we measure the angle anti-clockwise. And the angle between F2, which is 80, and x-axis is going to be 120. And this is how we measure the angle. We are going to measure counterclockwise to our F2. So this is 30, this is 60, this is 30. So you can sum them to get 120. And the angle between F3 and x-axis is this angle. Look at it here. You sum all this one. You have 120, 120 plus 60, 180, 180 plus 40. That will give you 223 degree. So from here we have all our parameters to evaluate the x component and y component. The x component is given by this relation: f1 cos theta 1 plus f2 cos theta 2 plus f3 cos theta 3, and y component is f1 cos sin theta 1 plus f2 sin theta 2 plus f3 sin theta 3. So we are going to substitute these values here and evaluate our x and y. So let's do that in the clean of a page. Okay, so to evaluate our x, we are going to put our f1, which is 100, times cosine of theta 1, which is 30, plus f2, which is 80, times cosine of theta 2, which is 120, plus f3, which is 40, times the cosine of 223. This will give us our x, and when you evaluate this correctly, you are going to get 17.3484. Remember, your calculator should be in DEG mode, not a RAD or GRAD. So if you do that, you don't have to. The answer is going to be this. Then y is going to be 100 sine 30 degree plus 80 sine 120 degree and plus 40 sine of 223 degree. The same thing here. Your calculator mode should be in DEG. If you do that correctly and you substitute the values, you are going to get 92.0021 to 4 decimal places. So our final resultant R is going to be the square root of x square, meaning that we square this, plus y square, and when we evaluate the sum and evaluate the square root, our final result is going to be around 93.6 Newton. This is our final result. And if you could recall, the previous result we obtained under this case of 3 vector is also around 93.7, which means they are very close. Okay, so thank you very much. I hope you will easily see the advantage of this component method. It's a bit more easier and more easy to evaluate. The only problem is evaluating those angles. When you evaluate those angles, you can evaluate the final result. So thank you very much till we meet in the next section.